Okay, in this video, I am going to practice some sampling distribution of mean with you. Okay, starting with a population that is not normally distributed, that means we care about the sample size in this case. So, all right, restaurant bill at a given restaurant have an assumed population mean of $32.40 and the population standard deviation is $8.16. The data is heavily skewed to the left. Explain why you cannot determine that given bill will be at least 13.5. Because we don't know the probability distribution, since this is heavily skewed to the left, so we don't know the probability distribution. So we can know. Because everything that we did on GeoGebra is either binomial right now or normal distribution. If there's skill data, we don't know how to find out, hey, how can that be at least $13.5? Okay, can you estimate the probability that the next 5 bill will be average at least $13.5? Discuss each condition for using a sampling distribution of mean. So the condition for using sampling distribution of mean, what is the condition? The condition is the central limit theorem, which is the randomization, independence. So we assume that each bill is going to be independent. I'm not going to charge you more because the next person charges you less. So they're independent. And every people that come in the cafe is randomization. So now it's the sample size. However, in this case, the sample size n is equal to 5 because it's next 5 bills. This seems it's not big enough to me. So we might not be able to do that. Okay, so the next one is, if we take the average of the next 50 bills, would all the conditions be met? Well, 50 sounds like big enough. So let's say by the central limit theorem, we got independent, each bill is independent, and each guess is randomization, and the sample size. N equals to 50 sounds like a big enough. So yes, all conditions are met with the sample size equal to 50. So define the model with its parameters. Draw and label it. So since this is going to be a sampling distribution of mean, so we want to let x bar, not s, x bar, be the mean cost of the next 50 bills. And our sampling distribution mean is going to equals to the population mean, which is, in this case, is $13.40. And our sampling distribution sigma is going to equal to the population sigma and then divided by the square root of the sample size, which is $8.16 divided by square root of 50 equals to $1.1540. Okay, so our x bar follow a normal distribution with the mean is 13.240 and sigma is 1.1540. And the graph is look like this one. In the middle, it's going to be 13.2.5, and the first is adding a standard deviation from the sampling distribution, which is 13,355. Adding the second one is 13,471. Subtract 1 is 13,125. And then subtract 1.15 again, you will get 13.1. So that's your distribution model. It's going to look like. How likely is that the next 15 bill have an average at least $35? So by drawing this graph, you might notice that $35 is going to be outside of 2 standard deviation, maybe approximately here. Remember that when we talked about the outliers in the normal distribution, if the value is outside of 2 standard deviation, it's going to be very extraneous, very less likely. So that means you expect it to get a very small probability. So now we can do that. So the probability that X bar, because it's the mean of the next 50 bills, so that's why it's X bar, not X, greater than 35. Let's use GeoGebra. This is 13.2.40. And the sigma is 8.16 divided by square root of 50. And we want X to be greater than 35, which is 0.0121. In this case, is 1.21%. Okay, so that's it for this video. Let me know if you have other questions.